In this year's symposium, we are exploring how New York is growing and leading change in our food system through food waste diversion, sustainable farming, and more. So let's get to it. Please join me in welcoming Benjamin Holton, the Ronald P. Lynch Dean of the College of Agriculture and Life Sciences at Cornell University, and Dr. Saharamoon Chippotin, the Executive Director of the Foundation for Food and Agriculture Research, for a fireside chat about tackling on-farm R&D needs to achieve net zero dairies by the year 2050. Please give them a warm welcome. So we're thrilled to have the both of you here today. And I thought we could start by looking at the big picture, and then we can drill down into some specifics and some really valuable information. So starting with big picture, I'll start with the Dean, if that's okay, Dean.
Sure, yeah.
Okay, great. Why are agriculture and food so important from a climate change perspective?
Great. Well, first of all, thanks a lot for this opportunity. I mean, to watch Grow New York continue to grow, and that last pitch was just so exciting. I'm still trying to get over all the outstanding innovations that are happening here. I think, and I'm delighted to be up here with Saharamoon to have an opportunity to talk through some of the, I think, issues and opportunities. But I guess the big picture, we have an amazing global food system. We have bent the rules of the environment for hundreds of years through irrigation, new seeds, new varietals, fertilizer. All these amazing innovations have happened that have created a food system that's capable of meeting billions of people's needs on a daily basis. It's an imperfect system. Mm-hmm. There's still at least 1 billion people who are not getting enough food, and about another billion more that are suffering from micronutrient deficiencies, what we call hidden hunger. So we have this ensemble, this global food system, and I think the challenge is it's quite vulnerable to weather extremes. So as we have bent the rules on the environmental systems through which we can grow food, we can only bend those rules so far, because when you run into droughts and heat waves and wildfires and rising sea levels, it puts pressure on the food system that we just can't adapt to. I think we still have great opportunity to innovate through adaptation and to tunnel through the challenge, but it certainly is going to require a whole new realm of thinking, a new organizational capacity for our food system. So where do I see the future in the big picture? I guess I'll close with this to your opening question. The food system is vulnerable, but it also can be the most powerful weapon in the battle against climate change. And my own research and countless others have demonstrated that we can revolutionize the way in which we grow food so that it is a negative carbon economy, one that pulls more carbon dioxide out of the air than is generated through all the greenhouse gases, and it can do so while meeting maybe 9 to 10 billion people's needs on the planet. It's within our capacity, but getting there is a major, major, major challenge.
Very exciting. So thank you, Dean.
Sure.
How about you, Saharamoon?
Sure. Well, I think you said a lot of it, and maybe before I answer even, I'll just take a moment and introduce my organization. Not everyone knows who we are. The Foundation for Food and Agriculture Research was established by Congress and given the mandate to form public-private partnerships to support the food and ag research that our food and agriculture system needs to stay competitive and to address issues like productivity and environmental sustainability. And we were given a very unique funding mandate. For every dollar we receive from Congress through the Farm Bill, we have to match it with a non-federal dollar, which is a fantastic mandate because that actually really requires that everything that we do, all the projects that we support are done in partnership with others in the industry, in the ag and food sector. So we partner with companies, we partner with foundations, with universities, with state and municipal governments, with other country governments, and we jointly fund research that addresses the biggest challenges in food and agriculture today. And so this intersection between climate and agriculture is so critical, and I'm often struck how agriculture is seen as perhaps a source of our problems. There are many who would like to blame the food system for everything that's wrong with the world. But I'm struck by how agriculture can really be a solution to the problems that we're facing in terms of it, certainly agriculture and the way that agriculture is done can have impacts on the environment. It can have impacts around emissions, a very large source of emissions, water, soil health. But the way that agriculture is done can really mitigate that. As you said, you can capture carbon through agriculture. You can deliver the benefits that people need, the healthy foods that people need to be productive. And so I really like to think about the optimistic and exciting aspects of food and agriculture in addressing things like climate change and other environmental issues.
Thank you so much. So let's dig in. When you think of dairy farmers and dairy farms, you think of a lot of wonderful things in food production, but there is a concern regarding methane and methane emissions. So let's talk about what is it about methane that makes it a critical target of slowing the pace of climate change? So would you like to start?
Sure. Methane, probably most folks know, is a very potent greenhouse gas. It has a much greater impact on holding temperature than carbon dioxide does. And it's also relatively short-lived, so that the flip side of that is it makes it an attractive target. If you can reduce methane emissions, you can have a big impact on overall greenhouse gas emissions, and you can do so in a relatively shorter time frame. Agriculture is a pretty significant source of methane emissions in the United States, and dairy and beef sectors are a pretty significant source of those methane emissions. And there's a couple opportunities, two major opportunities, the enteric methane coming from cattle, and then the methane coming from manure. And so it's an attractive target in the sense that there are solutions. You can do something about it. It's not easy. There's some pretty difficult challenges to reducing those methane emissions and thinking about how to measure them. It's hard to measure gases, right? But it's one where you feel that if you can tackle this one, you could have a pretty significant impact on lowering emissions. And fundamentally, we have to lower emissions in every sector. And agriculture is one of those sectors. And I think there's some real opportunities to do that.
Dean, what are your thoughts about this?
Well, I think that was super well put. And, I guess the only thing I would maybe just add to that is there's a win-win opportunity with methane. So oftentimes when we think of CO2, we're talking about a greenhouse gas that has a very long lifespan of hundreds of years, if not thousands of years through the system. And so when you reduce CO2, the benefits are widely distributed, and it takes a while before you start to see them. And we do need to cut CO2 rapidly. Methane is one of those really interesting molecules that reveals more significant real-time benefits, to your point, Saharamoon, because it's short-lived, it's potent, and when you reduce the emissions and you bend the methane curve, you bend the warming curve. So if we're talking about avoiding 1.5 degrees Celsius of global warming, which we've already hit temporarily, we may exceed, and that is a trigger point for the planet, methane is the most important tool in the toolkit to slow the pace of warming and bring about benefits for these weather extremes so they're not as extreme as they otherwise would be. And then the other side we can talk about is methane is a loss of energy from a cow. So what if you don't lose that energy? Well, you could get 12% perhaps of an efficiency gain by cutting methane emissions. So now profit goes up 12%, all these things. So it's really in this interesting space where the co-benefits can be experienced in real time on short time scales, and that's why I'm really excited about what agriculture can do with methane.
So it can be a win-win for everyone
Absolutely.
involved.
Absolutely.
Yes.
Yep.
So just carrying on with that thought, Dean, what are some promising methane-reducing technologies coming out of R&D? Because we know Cornell University is a global leader in agriculture, and what do you see?
Yeah, I would love to hear Saharamoon's perspective because she has such a great vantage point. I think what we're seeing in New York State is a real ambition among the dairy community to motivate solutions that are net zero. And some of those innovations are being tested out in our labs right now and in our farm fields. So it's really exciting time. I don't think there's ever been a more exciting time to be engaged in agriculture and food than now. But some of the examples would be feed additives that, you know, people say that cows have 4 stomachs. I'm sure this crowd knows that's not true. They just have 4 chambers in one stomach. But the rumen, it's like the final frontier, like Star Trek, the final frontier. The rumen is the final frontier of innovation because there's all these little creatures living in there, these microbes, and they're producing methane. And if you feed the cow differently, you can cut those emissions by 70%. So whether it's feed additives, seaweed, brown algae, things like that. There's also ways in which you can vaccinate animals. You can use probiotics, but all these things need to be tested because there's a lot on the market. There's a lot of great excitement, but we have to make sure it's science-led and it's evidence-based. And this is happening right now at Cornell in our new methane stalls, where we have 4 stalls working in partnership with Cargill and local dairy, as well as ag and markets, to figure out how we can measure in real time emissions when you intervene, and then ensuring that the product is safe. Because if the milk ends up with chemicals that are bad for people or bad for the environment or something, that is not a win-win. So we're on top of that, and that's where a lot of the cool innovation's happening.
It sounds really cool. How about you, Sahara Moon? What are you seeing in the R&D space?
Yeah, so FAR funds several projects in this space, and you know, you highlighted some of those technologies, but one of the, just wanted to highlight one way that we've worked is FAR often will form consortia. So consortia of funders who want to invest jointly come together and guide investments in a space. And the topic of methane emission from cattle was so great that we formed the Greener Cattle Initiative. And that brings industry players together all along the value chain who have a common interest in cutting methane emissions. But that's such a big problem. No one company is going to invest in that and solve it on their own. But coming together, they can do that pre-competitive research and really de-risk that investment. And you know, just thinking about, I'm going to read these players because I think it's so fascinating that we can get all of these folks around a common interest. We've got ADM, Elanco, Genus, Nestle, GMH, JBS, the Council on Dairy Cattle, a New Zealand organization, the National Dairy Herd Information Center. So all of them coming together to tackle this problem. FAR and the Innovation Center for U.S. Dairy pulled them together and formed this consortium and brought them all together, and then did that work of like, what are the research priorities that we can tackle here? What are the research needs that the industry have? And they settled on a few things for this consortium. One is doing research on delivery mechanisms. So you mentioned some of these fantastic technologies. How do you get them into the cow? Feed additives are great, but what if it's grazed, right? When do you do that intervention? How can you build those delivery mechanisms into the existing production practices that are already having on the farm? What are some early life interventions that will have impacts over the life of that cow or into the progeny? What are the synergies and interactions between these? So individual technologies, you might only be able to apply a certain amount before you start impacting, like you said, the milk quality. How can you pile those on and have a greater impact? And then what are those trade-offs? What are the implications for production? How do you maintain the milk quality, the nutritional quality, the flavor? So those are the research sort of general areas that this consortium is investing in, and they put out a call for proposals, and they already have a first round of proposals underway looking at things like methane inhibitors, diet additives, and then also doing some breeding. There's a pretty decent range in terms of cows and the degree to which they emit methane. And so thinking about how you can maintain that milk production but bring in some genetics that would have lower emissions is pretty powerful. And then they've recently did another call, and we'll have another set of projects coming out soon.
So a lot of advancements are underway, and there are a lot of opportunities out there, but oftentimes with opportunities, there can be challenges that arise. So Sahara Moon, what are some of the challenges that you're seeing as far as scaling these technologies?
Yeah, it's challenging. I think, you know, I kind of step back and think about it, like how do you really make this happen? And you want to think about the cost of the technology, obviously, and how you're incentivizing it, and who needs to play a role in that. Scale is a big issue. Something that's going to work on a large farm may not work on a small farm. The regulatory environment is going to be a challenge in terms of, you know, you might have a technology, but is it approved for use? And as I mentioned, the delivery mechanism can be a challenge. And also, how do you know that you're having the benefit that you're having?
Exactly. So Dean Holden, what do you think about this?
Well, I think Sahara Moon hit all the major elements here. I guess I would point out like some work by EDF that was advancing, you know, through FDA approval Because oftentimes we don't think about these regulatory barriers, and these can be the key constraint that unlocks an innovation. But there's a lot of approval and there's a lot of bureaucracy that you have to work through if you want to bring a new technology, because you want to make sure it's safe for the animal, it's safe for the consumer, and ultimately for us too, we're testing to make sure that the benefits are real. That just because one study claims they saw a big reduction doesn't mean that that's evident when you go to entire herds. So I think our job as a university is really be autocatalytic with the partnerships and make sure that everything is science-based and that we're leaning into where the community wants us to go through what we call a model of co-creation with our dairy community here in New York.
So at Cornell, oh, go ahead.
I was going to add on, when we were talking about, we're talking a lot on the enteric methane, but there's a whole nother world of methane that comes from manure. And that comes with a whole different set of issues and how you address that. That's another area that we're at a much earlier stage. We've brought the community together to help us really think through what are the research priorities around reducing emissions from manure, and how can you better manage that manure. And again, another one of these, I think, opportunities where you can generate value from that in addition to mitigating the emissions.
Exactly. So at Cornell and at FAR, we're doing the hard work of the research and the development and the innovation. And sometimes, you think about commercialization too, and how are we looking for commercialization partners as far as getting this out of the theoretical and into the marketplace and making a huge difference. So Dean, you want to address
well,
that?
I guess there's so much opportunity here. We have the Center for Regional Economic Advancement, we have Cornell Agritech, we have Cornell Tech. There's so many different ways, the Center of Excellence, in which we are arrayed toward innovation and creating an innovation hub. But one thing I want to highlight, and I want to shout out to Julie Suarez, Associate Dean and the college and Director of Translational Research, is this opportunity we have in front of us to partner with the National Science Foundation, which would bring together a really incredible coalition to develop a world-leading innovation ecosystem around this region, partnering with Cayuga Milk Ingredients, Ag and Markets, Environmental Defense Fund, Chobani, the Cornell, different elements of Cornell. And this particular grant, if we're successful, would be about job creation, creating hundreds of jobs for the region, new innovations, new startups, and creating an on-ramping approach for entrepreneurs to come into the dairy sector in all elements from the full supply chain and bring an innovation in that could be net zero, non-emitting, and profitable. So again, I don't think that's outside the realm of what we can do. I'm a big believer in hope, but hope favors the prepared, and so we have to get the resources. We got to get, and we have the team together, and we're really hopeful that we're going to enter the next stage of this NSF Engine sustained dairy project.
I think it's so wise to bring all the partners to the table and have them working together and pulling together. That's really exciting. So, what about you, Sarah Moon? Like, what are you doing to bring in the network so that there can be commercialization of this?
Yeah, I think that's such an important piece, because obviously the research can happen and the research won't really get anywhere if there's not someone to bring it to the farmer. Like Norman Borlaug used to say, take it to the farmer, right? So how do you do that? You can't just sort of, here's the technology, go use it. And that's where industry is really critical. One of the things I love about how FAR works is because we're bringing industry in to help us co-fund the research, they're there from the beginning and they're seeing the technology as it's evolving, and they're often the ones who are going to be either developing it if it's a technology company, or figuring out how to insert it into the supply chain if they're a company that sources product. And then the other partner, the entity that always has to be at the table, is the farmer. And we saw the last pitch, I think that was developed on farm. And if every technology company had farmers in the room, I think you'd have that much greater success, because something can seem brilliant and it can seem like a wonderful solution. And then you take it to a farm and it doesn't fit into your existing production practice, or you don't have the right technical know-how to run a sophisticated piece of equipment. So bringing the farmer and the industry together with the researcher, I think, is really that can deliver the products and the innovations that can be used and can be applied in a real setting at scale.
And what incentives should we give farmers, or how can we get them to adopt these technologies, because I grew up on a dairy farm, and back in the day there weren't these kinds of options out there. But I see oftentimes farmers now get hit with all kinds of new technologies or opportunities. But the bottom line is always an issue too with farmers. And so what do we do, Dean, to get them really actively involved?
Well, one person once told me you have 2 ears and 1 mouth for a reason. So first you got to listen to what the real challenge is that the community is facing, as opposed to coming in and thinking you know exactly what the issue is. I think with methane, we're pretty aware that we're rowing in the same direction, but if the profit and the margins and the returns are not revealing themselves through a new technology, then we're asking way too much of this community that's already the backbone of our economy. I mean, we take it for granted, but DoorDash doesn't come without a farmer connected to it. But sometimes we think, oh, well, look, I'll just dial up the phone and here comes my ramen noodles or whatever it is. But the truth is, it took years for that food to actually make it to your plate, and we forget that. So I think the profit with methane might be realized through efficiency gains. As we mentioned, about up to 12% of the energy of the cow is lost to methane. What if you can recover that and keep that within the animal, and then boom, you have a higher profit margin on your milk. Moreover, we need carbon markets that are not bureaucratic, that are simple, with what we call MRV, measurement, monitor, verification systems. So these together combined, and I can talk more about some stuff we're doing there later, are what's going to be fundamental to unlocking the opportunity for farmers to get paid for the countless services they're providing society, which could be a massive climate service.
Well, great idea. How about you, Sarah?
No, I think you said it. It's how do you bring value to the farmer? And you can define that value in different ways. That value can be greater profit, greater sales of milk, or it could be better, healthier animals, such that you're not turning over your herd so often. So there's different ways to bring value, and farmers are extremely astute, and they understand the many different ways that you can bring value to the farm, whether it's improved environmental management from a better manure management practice, a healthier environment around your farm, whether it's sort of building out the long-term sustainability of your farm, or whether it's bringing you that annual value in terms of sales or reductions in terms of outputs on equipment or technologies. But I think that's fundamentally it. If there's a functional carbon market, that's another way to bring value to the farmer. But what we hear from farmers, we did a series of consultations last year, is it's kind of crazy out there. Everyone's coming up to you with, I've got this verification process and this app you can use, and how do you have any confidence that, one, it'll deliver the information you need to get that value from the market, much less are you actually having a reduction in emissions. And so the upfront research around validating these technologies across multiple environments, the research around having measurement tools that can accurately measure emissions such that you're actually having the impact, so that the investors will have the confidence that this is a technology that can gain that credit. I mean, that's just some of the upfront work that has to be done so that farmers can have confidence that if they adopt a new technology, they will be able to demonstrate that they have met the criteria needed to then gain that value.
Maybe I could just add, so I think that is such a great point that Harmoon makes, especially when you consider that it is kind of Wild West when it comes to carbon. There's a lot of possible snake oil out there. But that happens when you're driving innovation. There's going to be those that rise up. In the end, it's kind of Darwinian, but we got to make sure that we have science-based verification systems. So one grant we got in partnership with the USDA is called the New York Climate Connects grant, and that's in concert with Ag and Markets and Department of Environmental Conservation. And we have computer scientists using large language processing models, AI, machine learning, real-time measurements to create trustworthy platforms for farmers to engage in carbon trading. And then the markets, the financial markets, can ultimately trust these platforms enough to start sending resources to them. But this still continues to be a very gray area that drives me a little nutty, because I think if it's not science-based and if it's not verifiable, ultimately it's not going to win the day, and then we'll end up in a worse spot. because now we think we're getting carbon out of the air and we're not. And there is a global challenge. This is about food and dairy, but it's also about the future of this planet. And we need tools and technologies that work and that we can trust. And I think that's kind of the race that we're up against right now.
I think trust is the key word here. So you're both working on projects where you're bringing different industry players together, which I think is so smart, and they're each playing a role. But from your viewpoint, what are the different roles that people can play as far as adopting these technologies? And if you think of the different people who may be involved, so Dean, what do you think?
Well, I guess an organization like FAR is so critical, I would say, because there's this really important need to develop private-public partnerships that are based in university research and evidence that I think are going to be the ones that help us de-risk the innovations that we're going to be asking our farming community to embrace. And so I think that the more you are able to assemble groups across the full supply chain, even groups that normally wouldn't mix, as they say, I think you have the greatest chance of success. So that Sustained Dairy Grant I mentioned, the Net Zero grant that we're competing over with NSF is doing just that. And that's the kind of example where you have industry, universities, farmers, new innovative technologies, and you have a platform you're creating for new businesses to launch and create jobs, are where we're going to see the greatest speed with which we can act and the greatest impact for the region.
Your thoughts, Sarah Moon?
I think you said most of it. I think just to reiterate, there's real power in bringing together different sectors of an industry, whether it's along a value chain, the players you need, or whether it's competitors. We have a consortium, it's in seeds, but it does bring together competitors in the industry who, again, they all need to solve a common problem. They don't want to be the only one to invest if it's going to generate a common good that everyone else is going to use. But if you can get them in a safe space and they can collaborate with each other, we've had private partners say, this is amazing. I don't get to be in a room with my competitors talking about how we can address these challenges together. But there is this space that sort of sits between the traditional public sector research investments and the private research that a company does. And the more players you can bring into that space, it's really powerful. And you can generate technologies and you can be in that translational research space where you're really user-driven and you're developing the technologies that society needs, that industry needs, that farmers need, and doing it in a way that has people really focused on how do I get it to the next stage? How do I get it to the farmer? Because they've made that investment. Those companies have put their own investment into that, and they're really incentivized to see that through and to make sure that it comes to fruition.
Great answer. So Dean mentioned measurement, monitoring, reporting, and verification. And so what is the MMVR work needed to assure market certainty of greenhouse gas emissions and enable dairy farmers to receive compensation? So Dean, what are your thoughts?
Well, so I actually work specifically on this area too, so I have quite a bit of experience. I launched a business a few years ago where we're applying rock dust that we take from mining operations. It's like a byproduct that usually would be buried back in the ground. And we integrate that into the soil. And then once it's integrated in the soil, it has this amazing capacity to act as a sponge for carbon dioxide and lock it up for thousands of years. And I started leading some science on this technology maybe 8 years ago, before many people were kind of looking into it. And then suddenly you find yourself as an expert because no one else was doing it, and you're like surprised, because the more you do something, the more you realize you don't know. And so that's where my role has started to kind of focus when it comes to this kind of technology. But the idea that we're working on now, and many other groups are working on, is AI-powered modeling tools that take satellite data, sensors, field experiments and trials, working with farmers, and integrating them over time to develop a truly predictive analytics that then MMRV can recognize. But that requires working with a lot of partnerships. So we work with NGOs on this, we work with industry partners, we're funded by the Grantham Foundation, and next week I'll be working with the EDF in New York City on, do we create a standard for this technology? What is this technology standard supposed to look like? So we have, I think, a long ways to go. I say wild, wild west because it really is. It might be the wild, wild east, because we're on the East Coast, but regardless, it's going to be exciting. It's very exciting, but it has to be science-based, and we have to avoid the hype cycles that can stop technologies from really meeting their intended purpose. So MMRV, it really just means we trust, we can verify, and then we can sell the carbon because we know that it actually is carbon that has been consumed through some sort of strategy, whether it's soil health or, in this case, thinking about methane and methane monitoring.
How about you, Sarah?
Well, I know you were joking when you said, you became the expert on this, but you really are the expert. So I think he said it. I think, that phrase, the Wild Wild West, I can't tell you how many times I've heard that when I'm out there talking to people about this. It's sort of funny. It's become the catchphrase, but I think it's really true. There is no way for your average person, farmer or otherwise, without spending time becoming an expert in this, to know which system they should be using or what app they should be adopting in terms of verifying the practices that they're doing on their farm, that they will deliver the benefits that we need. And as you said earlier, it's not just that they will check the box so they can get their credit. We don't want to be adopting these technologies if they're not actually going to be solving the problem. I mean, that's, to me, is the biggest one, is we need to be extraordinarily careful, because if we set up a system that rewards the wrong practice because our measurements weren't good, we're not going to be taking carbon out of the atmosphere, and we're not going to be, that's what this is all about, right? We want to do it in a way that brings those additional benefits to farmers in terms of increased production and so forth, but fundamentally we are trying to solve that problem, and we have to get it right.
I guess the way I think about it too is a grand challenge is, some of you may know the Wizard of Westwood. John Wooden, like the most famous basketball coach, won out like 10 NCAA titles at UCLA. He used to always say, be quick, but don't hurry. And I think that's where we find ourselves. We have to be quick, but we better not hurry, because when you hurry, you make mistakes. So how do we be quick? Well, we're quick when we work together and we partner and we learn from each other, and then we fail forward as opposed to failing back, which is a real concern right now.
Yeah.
Yes. So there's a question regarding enteric methane. So why should we focus on enteric methane as a strategy for slowing the effects of climate change? And related to that is, how has its potential been assessed? And why does it compare favorably to other mitigation strategies? You want to start, Sarah, on one?
Sure. I think it's a yes and, right? We're not going to get there by focusing on one mitigation strategy. No one sector can completely eliminate its emissions overnight. But if you're looking at the biggest emitters and systematically going through and determining your targets across the board, then you start to get there. And so methane is one of those. It's a real opportunity because it has such an outsized impact. It is such a potent greenhouse gas. If you can reduce methane emissions, you can have a significant impact. And enteric methane is a big one, and we know enough to know that there are solutions. We've demonstrated them in individual situations. We understand some of the trade-offs. And so it feels to me like it's at the right point to bring that translational research approach and say, okay, here's what we know about genetics, about emissions, about the microbiome, and now let's put it into practice, and let's do that very systematically so that we can give cattle producers, dairy farmers, the confidence that they can adopt this technology and see the changes that we're anticipating.
Good point. Yeah, I think, and Sahara Moon mentioned this earlier, but there is a vision for some of this. Like, it's a little, it can look like science fiction, but we have all these vehicles now that are non-emitting vehicles, right? They're called electric vehicles. Can we have zero-emission cows that are bred to be zero-emitting cows? I think that is the future. That's going to involve synthetic biology and genetics and breeding. And I don't think we're going to see that breakthrough next year or the year after, but I think within the next 10 years, we're going to see such radical progress in what the microbiome of the rumen is all about. And can you start finding low-emitting, high-producing cows when you start doing these assessments and tests? So I think that's a critical opportunity. But again, methane, it's the ghost pepper sauce of the greenhouse gases. A little bit goes a long way, and it's kind of dangerous because it brings about a lot of heating. And in fact, if you look at global models, they would say that about 20 to 25% of all the global warming we've seen so far has been driven by methane. And even though cattle are only 7% of global emissions based on a lot of estimates, and just a couple of percent here in New York State. It doesn't mean those emissions don't add up, and it doesn't mean those emissions don't have a real opportunity to bend the warming curve quickly. And I think that's where I want to see incentives. Let's unleash incentives and get our farming community rallied behind this challenge, and I bet you we can solve it. But let's make sure the federal and the state incentives kind of line up, as opposed to creating policies that are really not conducive to where we ultimately want to go. I do think there's a big role for federal government.
Yeah, I think so too. And what do you think, Sahara Moon, about that?
About the role for federal government?
Yes.
Absolutely. I think a lot of people in this space are looking to the USDA to set some standards around carbon accounting. And I think they can be very, very powerful when they do that. I think that, I mean, policy in general drives so much. And policy obviously is informed by science and needs that scientific basis to form good policy. But the policy itself just needs to be designed to have the outcome you're looking for, and needs to be designed in a way that it is sensitive to what the industry needs, what the industry can accommodate. And so it doesn't have to be a regulation. It can be truly, you know, you need someone to stand up and be like, okay, we're going to do this work of bringing everyone together and establishing the standard and agreeing on the ways that you can measure emissions. And the USDA or another entity is one of those conveners that can do that, and that has the credibility and the voice to be able to get everyone lined up together to really bring the clarity to the sector that is needed to drive the investment, to drive the adoption.
So real focus on carrots versus sticks, right?
Sure.
Yes.
Carrots, and if I could have one other soapbox moment, well, it's that we're losing in R&D funding in the United States right now when it comes to agriculture, because we are behind China, we're behind Brazil, and we're behind the EU in the total spend of R&D investment from the federal government into agriculture at a time in which it is amazing what's happening with digital ag, new crop varietals, synthetic biology, controlled environment agriculture, and we have these climate change impacts that are hitting us and are going to continue to hit us. So now is not the time to be stopping the investments. Now is the time to triple the investments, in my opinion, for where R&D funding needs to go for agriculture if we want to have a safe, healthy, and resilient food system, because climate change is going to keep happening. It's going to get worse, and we need to do something about it to make sure that we have resilience built into our food system, because when you lose food, that's when it kind of all comes to a close. And that might sound a little dystopian, but I think we've already seen cases where we've seen a collapse of crops because of widespread climate impacts, and that is a part of our future, so we have to be ready for that.
So you talked about tremendous acceleration in the next few years, right? And you mentioned artificial intelligence, and could you explain that a little bit more? How does AI kind of factor into this whole effort?
Did you want to take it?
Go ahead.
Okay,
Go
well,
ahead.
I think that it comes in so many ways. It's just like if you pull on any string of the food system, you will find AI connected to it at some point. And that's everything from how you process and distribute resources and materials more efficiently, to how farmers are deploying the use of AI to figure out when they should be planting, when they should be irrigating, when they shouldn't be irrigating. You know, there's drones and all sorts of information being brought into the environment right now. Robots, applying pesticides as opposed to broadcasting. We have robots now that can put a little dot of a pesticide onto one plant at the strategic location where there's actually a pest appearing. So like that is all going to be driven by AI, because you can imagine just the case of the robots. They go to a field and they look like dogs. They're a little bit frightening actually, but they go to the field and they have scanners on them, and they can read the light information, and it's built in. It's just like built into their brain, which is then built into an algorithm. And so they can identify, okay, there's a little bit of chlorosis on this plant, or this plant needs a little more fertilizer. It's precision squared what's going to be happening. And the innovations are starting to come together. But that's just one example of where AI is revolutionizing our ability. MMRV, which we talked about, that's going to be AI driven. So AI is going to bring about a lot of upside, and it's going to bring some downside. So I don't think we should be full on AI all the time. We need to understand how AI is going to work and how it's going to support new farms and be supporting equity and justice in our food system, which is a very important question for us. But anyways, AI, yeah, you hear it a lot. It sounds like a buzzword, but it's happening. It's happening all over.
I think absolutely. I think a place where we're going to see really productive application of AI is actually in research and accelerating the research enterprise. And especially when I think about the great exciting things that can happen with AI, but also the concerns around if it's not used well or if someone doesn't know how to use it. How can you validate the information you're getting? I think pushing AI out there to be used by the general public, we're not quite there. People don't know how to use it and don't know how to evaluate it. But I think using it in that research space where you have users who are able to be more discerning and can use it to speed up processes. We were talking about evaluating different approaches to methane reduction and combining those. You can use models to think through what are going to be the scenarios and get you to where you can test sooner, so you know you're not testing everything, but you're testing those scenarios that really are going to be more likely to deliver, and that's where an AI tool can really help you in the genomic modeling and the microbiome and so forth. So bringing that in and helping us to, as you noted, the research dollars are extremely limited. The US has not made the investments in public research that it used to make. How can you stretch those further? How can you get to more variables, more experiments in a way that you know you're going to get the results you're looking for? So I think it's a really valuable tool.
That's a great point.
Thank you for that. So let's talk about milk quality for a minute and how this all kind of comes together, because obviously the farmers are concerned about milk quality. The companies such as Chobani working with Cornell and this is exciting new dairy project, and they're going to be concerned about milk quality. So are there tensions out there? Are there tensions with enteric methane reduction and milk quality, and how can we address those?
Absolutely. I think each of these technologies needs to be evaluated very carefully for its potential impact on milk quality in terms of taste, nutrition, fat content. Some are extremely valuable to a point, and if you apply too much or you deliver too much, you'll start to have problems, but you can get part of the way there. So thinking about what are the different combinations of these, there's software that's being developed to help farmers formulate their feed better. There's a number of different approaches you can use, but that needs to be sort of one of the first things that you're doing as you have something promising. How are we ensuring that the farmer is going to be able to continue to capture that value from their milk because it's high quality, it's nutritious, it has the right parameters that it needs to be on the market?
Dean,
Yeah,
your
well,
thoughts?
capturing the value from milk is, I think that's a great summary point on what we need to continue to think about. I mean, there are trade-offs, and I would say, how do we create trade-ons, if that word exists? Because you can imagine tension as a negative thing. Tension can actually be positive in a way of promoting new science and new knowledge. Fundamentally, we have to think about the co-benefit space through which a technology can not only help produce better milk, but also cut emissions. And I do think that's well within the option space for this technology. But one example that we have to, so seaweed, and we've probably read about it, you can go online, read about, okay, seaweed, brown algae, red algae, this could actually reduce emissions if you feed it to cows. There's a lot of questions about where you get the algae from, where it's grown, supply chain, is there enough? All right, but I don't think we have to have one solution, by the way. We can have thousands of solutions to this problem, so we gotta be a little careful about that thinking. However, the bromoform, which comes from the brown algae, is actually carcinogenic. Okay, if that ends up in the milk, okay, now we have a cancer-causing agent that could end up in the milk. So like what we're doing at Cornell with Joe McFadden's work with these methane stalls, they're measuring milk quality while they're looking at emissions simultaneously with the different interventions. And that's to ensure that it's safe, it's healthy, and that ultimately it's a technology that works. And we have to look at it holistically.
Right, so the goal is doing both at the same time.
100%,
Yes.
yeah.
So we're almost out of time, but Sahara Moon, would you like to give some wrap-up thoughts?
Well, actually, you just reminded me, one of the researchers that we're supporting is developing a milk-based test to assess methane emissions. And so I was just thinking, you know, can you combine these and get some synergies? What if you could test the milk and at the same time assess if your quality is staying high and what you're getting as far as emissions? So I think it's that kind of creative thinking that we're going to need here. This is a big problem, as I said. No one entity is going to solve it on its own. We're going to need multiple solutions layered on top of each other, and we're going to need the brightest scientists and the most astute practitioners and producers to really think about how to bring this together.
Thank you. Dean?
Ditto. I think also where I started, agriculture can be the most powerful weapon in the battle against climate change. And that's from carbon removal, that's to fertilizer technology. Methane is a key element of that, manure management, enteric methane. And we really need to create incentives around the farming sector so that they can innovate into this space for us. And I think you'd be amazed what happens when you create the right kind of innovations, the right kind of incentives around that innovation. So I'm excited for the future of agriculture. I don't think there's ever been a more exciting time, maybe about 80 years ago when the Green Revolution was kind of getting going, but now is another one of those times. And we're here to kind of help move New York State forward, create jobs, and think about these exciting innovations. It's been great to think about this topic with Sahara Moon.
Well, thank you very much. Phenomenal conversation today. Let's show our appreciation to Dean Holton and Sahara Moon.